Once upon a time, there was a huge asteroid, and it was spinning around in space. It got attracted to the gravitational force of the Earth, and then all of a sudden it came like really close over here, and then started rotating around, and bang! The asteroid flew into Earth and blew up. All these bits of rock started flying around, and they went around and went around. Some of them joining, and then some of them blowing each other apart. Eventually, their own gravity collected them into one single mass. And then, pop, out came the moon. La 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 la, I'm spinning around Earth. Another effect of the big rock crashing into Earth was that the axial tilt was made. Originally, the Earth's axis was straight up and down. But as soon as the rock crashed in, it shifted to 23 degrees.
Before the actual tilt was made, the sunlight distribution across the Earth was all uniform. So it would be the same here, and the same here
Throughout the year.
But when the actual tilt came,
It was no longer uniform
because then it would be summer here,
because it would be tilted towards the sun,
and it would be winter here.
because it was tilted away from the sun.
But when the Earth went around the sun,
It would change. So then, as soon as it was halfway across the yearly orbit,
this would be summer, and
because it would be tilting
like that,
backwards, like this, yeah,
and this
would be winter.
would be winter.
So when the sunlight is more intense in the northern hemisphere, it will be summer, and at that same time, it'll be winter in the southern hemisphere. The turning point for the seasons is fall and spring, when it is mostly equal.
The relationship through the distance between the sun and Earth is nothing.
There is
It
no
does-
relationship between the sun's distance.
It does nothing. Big, fat nothing.
Zero. The distance doesn't have to do anything with the seasons. The intensity of sunlight across the Earth makes the seasons, not the distance.